Good morning, children. Welcome to my channel Maths Tuition Online. Before 3 videos, we learn about the properties of rational numbers. So today we are discussing about Abelian group. Abelian group. So once again, I am repeating the properties. See, closure property under addition properties. First of all, we can discuss about addition properties. Addition. That is first one. A1 addition means closure. A2 commutative. Addition A means under addition, commutative. A3 associative. A4 identity. A5 inverse. These are the 5 properties. So closure means suppose we can discussing natural number a plus b belongs to that particular number set or n or r or q or z, anything. Commutative means a plus b is equal to b plus c. Associative means a plus of b plus c is equal to a plus b plus c. Identity means a plus 0 is equal to 0 plus a is equal to a. Inverse means a plus of additive inverse minus a or minus a additive inverse plus a, which is equals to 0. These are the under addition properties. So here we are discussing about natural number set. Addition properties. Now we are discussing about natural number set n. N satisfy the closure property means yes only. Why? Because suppose you can take 2 and 3, the natural numbers, their sum is also a 2 plus 3 is equal to 5 belongs to n. So that's why natural number set is satisfy the closure property. Okay, and it is closure property under addition. Natural number set satisfy the commutative property means yes, 2 plus 3 is equal to 3 plus 2. A plus b is equal to, under root condition will be a plus b is equal to b plus a. Then it is satisfied. So it is also holds the commutative property. Associative, 2 plus 3 plus 5 is equal to 2 plus 3 plus 5. Yes, 2, 3 add చేసుకుంటే 5 plus 5, 10. ఇక్కడ 3, 5 యాడ్ చేస్తే 8 plus 2, 10. Both sides same results. So that's why the natural number set satisfy the associative property under addition. But identity means a plus 0. Property into a plus 0. You can take 2 plus 0. But a means 2. 0, it is not an natural number. So that's why the natural number set does not hold the identity property under addition. Inverse. Suppose you can take 2. Additive inverse is minus 2. Their sum 0 only. But here we can take 2 is a natural number. Minus 2 is not a natural number. Does not belonging to the natural number. So that's why the natural number set does not hold the inverse property. Does not hold the inverse property. Why? Because if we are taking example, both are the natural number only. Natural number గురించి discussion చేసేటప్పుడు both are natural numbers ఉండాలి. 2 and minus 2 natural numbers అంటే no, 2 is a natural number, minus 2 is not a natural number. So that's why it does not hold the inverse property. This is natural number set. Okay, and whole numbers. Whole numbers ఏంటి extra. Whole number ఏంటంటే extra 0 along with natural number 0 ఉంటుంది కాబట్టి a plus 0. A plus 0. Alright, it shouldn't. Next, whole number set. We can discuss about the whole number set. The whole number set satisfies all the natural numbers properties, and it has one more property, that is additive identity. Additive identity ఎందుకు చేస్తుందంటే additive identity ఫార్ములా 2 plus 0. 2 is a whole number, 0 is a whole number. మన natural number ఎందుకు చేయలేదంటే 0 is not a natural number. And additive inverse 2 plus of minus 2. Minus 2 is not a whole number. So that's why the whole number set does not hold the inverse property. Next after that, integers. Integers negative also is there. The integer set satisfies all the properties of whole number. It has one more property, that is additive inverse. Why? Because here 2 and minus 2 are the integers only. So that's why minus 2 వచ్చింది మనకి additive inverse కు. ఆ మైనస్లో ఆ minus 2 అనేటటువంటిది integer only. Okay, so that's why it is the integer set satisfy these 5 properties. After that, q means rational number, our topic, rational numbers. Rational number set is q satisfy all the properties of integers. ఎందుకని n subset of w subset of z subset of q. ఇది నెంబర్ లైన్ సిస్టమ్ కాబట్టి z సాటిస్ఫై చేసిందంటే ఆటోమేటిక్గా q కూడా సాటిస్ఫై చేస్తుంది. ఓకే, దీస్ ఆర్ ద ఎడిషన్ ప్రాపర్టీస్. ఓకే, నెక్స్ట్ వి గో ఫర్ multiplication properties. Under multiplication lo property same, m1 closure, m2 commutative, m3 associative, m4 identity, m5 inverse. Okay, identity closure means a into b belongs to that particular set. Commutative means a into b is equal to b into a. Under multiplication, no, plus under addition means a plus b. Under multiplication means a into b. Associative property, a into b into c is equal to a into b into c. Identity element is 1 under multiplication. A into 1 is equal to 1 into a is equal to a. Inverse, multiplicative inverse, a multiplicative inverse is 1 by a, or 1 by a multiplicative inverse a, which is equals to 1. These are the properties under multiplication. Okay, now we are discussing the number sets. Natural number set satisfy the following properties. See, it is satisfy the closure. Clear, 2 into 3 is equal to 6. 6 is a natural number. Commutative, yes, 2 into 3 is equal to 3 into 2. Associative 2 into 3 into 5, which is equals to 2 into 3 into 5. ఎలా మల్టిప్లై చేసిన సేమ్ రిజల్ట్, 3 5s are 15, 30 వస్తుంది. ఇక్కడ 2 3s are 6 5s are 30. ఎట్లా అయినా సేమ్ రిజల్ట్. ఓకే, కాబట్టి ఇట్ హోల్డ్స్ ద అసోసియేటివ్ ప్రాపర్టీ ఆల్సో. ఐడెంటిటీ, ఏ ఇంటూ 1 అంటే 2 into 1. 2 and 1 are the natural numbers only, so it is satisfy the identity. Inverse, 2కు inverse multiplicative inverse 1 by 2. 1 by 2 is not a natural number, so that's why the natural number set does not holds the inverse property under multiplication. Okay, ఎడిషన్కు మల్టిప్లికేషన్కి తేడా ఏంటి? న్యాచురల్ నెంబర్ సెట్ ఎడిషన్లో ఓన్లీ 3 ప్రాపర్టీస్ a1 a2 a3, ఇక్కడ m4 దాకా సాటిస్ఫై చేస్తుంది. నెక్స్ట్ హోల్ నెంబర్స్ ఏంది? ఇట్ సాటిస్ఫై ద ఆల్ ద ప్రాపర్టీస్ ఆఫ్ న్యాచురల్ నెంబర్స్. మరి ఎక్స్ట్రా ఏముందండి? ఇన్వర్స్ ఉంది. ఇన్వర్స్ అంటే 1 by 2 కదా, 2కు మల్టిప్లికేటివ్ ఇన్వర్స్ 1 by 2. 1 by 2 ఈజ్ ఏ హోల్ నెంబర్? నో, does not holds the inverse property. Same integer also, 1 by 2 is not a integer, so integer set also satisfy all the properties of whole numbers, does not satisfy the additive inverse. Why? Multiplicative inverse. Why? Because 1 by 2 is not a integer. మరి 1 by 2 ఏమవుతుందండి? రేషనల్ నెంబర్. 2 is a rational number, 1 by 2 is a rational number, so that's why the rational number set holds the multiplicative inverse. Q is satisfied all the properties under multiplication. Okay, these are the properties. Okay, now we are discussing ఈ ప్రాపర్టీస్ యొక్క యూజ్ ఏంటంటే చూద్దాం. గ్రూప్ మీన్స్ ఎనీ నాన్ ఎంప్టీ సెట్ satisfy the following properties. First one, closure. Second one, commutative. associative, third one identity, fourth one inverse. Any non-empty set, any number set satisfy these four properties, then only we can say that it is group. And a group contains, along with group contains commutative property, then it is said to be a Abelian group. ఓకే, గ్రూప్కు ఏబిలియన్ గ్రూప్కు డిఫరెన్స్ అర్థమైందా? గ్రూప్ కావాలంటే ఎనీ, సపోజ్ ఎడిషన్ తీసుకుందాం, ఎడిషన్లో జెడ్ తీసుకుందాం, జెడ్ ఇంటీజర్ సెట్, ఇట్ ఈస్ సాటిస్ఫై A1 A2 A3 A4 A5 ఆల్సో, ఆల్ ప్రాపర్టీస్ని సాటిస్ఫై చేస్తుంది. కాబట్టి 4 ప్రాపర్టీస్ ఉన్నాయి కాబట్టి గ్రూపు, 5 ప్రాపర్టీస్ ఉన్నాయి కాబట్టి ఏబిలియన్ గ్రూప్. అదే డబ్ల్యూ తీసుకుందాం, డబ్ల్యూ సాటిస్ఫై A1 A2 A3 A4 బట్ నాట్ A5, A5 లేదు, ఇన్వర్స్ లేదు కాబట్టి ఇట్ ఈస్ నాట్ గ్రూపే కాలేదు కాబట్టి ఏబిలియన్ గ్రూప్ కూడా కాదు. ఓకే, ద ఇంటిజర్ సెట్ గ్రూప్ అండర్ ఎడిషన్ అండ్ ఇంటిజర్ సెట్ ఈజ్ గ్రూప్ అండర్ మల్టిప్లికేషన్. ఇంటిజర్ సెట్ మల్టిప్లికేషన్లో ఏం సాటిస్ఫై చేస్తుంది? M1 M2 M3 M4 ఓన్లీ, 4 ప్రాపర్టీస్. 5th ప్రాపర్టీస్ ఇట్ ఈస్ నాట్ సాటిస్ఫైడ్ ఇన్వర్స్. There is no inverse, it is not a group. But integer set is a group only under addition. Under multiplication it is not a group. But suppose you can take Q. Q is satisfy all the properties under addition and under multiplication. See, observe the table చూడండి. Q అన్ని ప్రాపర్టీస్ సాటిస్ఫై చేస్తుంది, 5 ప్రాపర్టీస్. So that's why it is an Abelian group. What is the best example of Abelian group? Q is a Abelian group. Rational number set is a Abelian group. Okay, Abelian group. In both binary operations it is an Abelian group. It is also satisfy the multiplicative distributive property. Multiplicative distributive property. Multiplicative distributive property అంటే every number set holds the multiplicative distributive property. Okay, that means A into B plus C is equal to, రీడింగ్లోనే ఉంది, A into B plus C, A is multiplied by B, AB plus A is multiplied by C, AC, AB plus AC. Any number set satisfies this property only. So any number set in both binary operations is an Abelian group and holds the multiplicative distributive property, then it is said to be a field. Field means in both binary operations Abelian group. Both binary operation addition and multiplication, and it holds the multiplicative distributive property, then only we can say that it is an field. Okay, it is an field. Okay, right, these are the properties of rational numbers. Okay, మనం ఇప్పటివరకు ఏం చెప్పుకున్నాం? రేషనల్ నెంబర్స్, వాటి ప్రాపర్టీస్ చెప్పుకున్నాం. నెక్స్ట్ మనం 8th క్లాస్ కరికులంలో భాగంగా నెక్స్ట్ వీడియోలో ఎక్సైజ్ ప్రాబ్లమ్స్కి వెళ్దాం, ఎక్సైజ్ 1.1. థ్యాంక్ యూ.